Welcome to solverfy.
Unfortunately, not all of them are typed properly, so next time please make sure that everything is written as it should be. The first reaction is the reaction between MnO2 and CO, which results in Mn manganese 2O3 and CO2. So let's balance this reaction. So briefly, for manganese, it's a 1 electron reduction. For CO, it's a 2 electron oxidation. That's why we have to add 2 before MnO2. And now let's see what we have with the balance. So 2 manganese on each side, 1 carbon on each side, and 5 oxygens on each side. So therefore, coefficients between before CO and CO2 are 1s. Okay, this one is balanced. Let's move on. Next one is copper 2O solid plus solid carbon forming solid copper and CO, which is gas. Again, here it's okay. Actually, yeah, it's gonna be it will be a 1 electron process for copper and 2 electron process for carbon. That's why if we are to balance it, we would add 2 before copper. So what else? Or actually, yeah, here it will be easier to write the electron balance. So 2 copper actually no, I'm sorry. Yeah, for 1 copper it's 1 electron process. For 2 copper it is 2 electron process. Therefore, to balance it, we have to add 2 before copper, and now that has to be balanced. So let's check what happens if we add 1 before carbon, 1 before CO. So we have 2 coppers on each side, 1 oxygen, 1 carbon. Yeah, everything is balanced. Okay, now let's move on. The next one is the reaction between C3H5 NO3 3 times. Decomposing into CO2 plus water plus nitrogen plus oxygen. Okay, let's see how we would balance it. So first, let's balance carbon, because carbon is only here in, I guess it's nitroglycerin and then CO2. So let's see what happens if we add 1 before carbon. So if we add 3 before carbon, so then, actually no. Yeah, let's balance nitrogen first. So here we have 3 nitrogens on the left, 2 nitrogens on the right. Therefore, we have to add 3 before nitrogen and 2 before substance on the left. So now we have 6 nitrogens on each side. Now let's balance carbon. We have to add 6 before carbon dioxide on the right. And so what? Now let's balance hydrogen. So there are 5 times 2, which is 10 hydrogens on the left. Then let's add 5 before water. Now let's see what's going on with oxygen. So we have 3 by 3 times 2, which is 18 oxygens on the left. On the right, we have 12 plus 5, which is 17. So it means that we need to add 1.2 before one half before oxygen to balance, but instead of doing this, we'll just double everything. So we will add 10 before water, 6 before nitrogen, 12 before CO2, and 4 before, I think it's nitroglycerin. Okay, let's check the coefficients now. So we have 12 carbons, right? 36, 12 nitrogens, 20 oxygen, 20 hydrogens, and 3 by 3, 36 oxygens here, and 12 plus, 24 plus 10 plus 2, 36 oxygens on the right. So now that's balanced. Okay, let's move on. Iron sulfide plus oxygen forming iron 2O3 plus SO2. So let's see how we could balance it. If we add 2 before, so let's add 2 before iron oxide, then we have to add 4 before iron sulfide and 4 before SO2. Now let's see what's going on with oxygen. Here we have 6 plus 8, no. So it means that, now I overestimated the coefficients. So you see it's always like a kind of a, we need a good initial guess. So let's add 2 before iron sulfide, 2 before SO2. Now let's calculate number of oxygens. No, now we have even oxygens on the left, on the right. So actually we need to add 4 before iron sulfide. So anyways, let's correct it back. So now let's check. We have 4 irons on each side, 4 sulfur on each side, and here on the right we have 8 plus 6, which is 14 oxygen, so we have to add 7 before oxygen. Now it's balanced. Okay, that's great. And we can move on to the next equation. Copper nitrate decomposes to copper oxide plus NO2 and plus oxygen. So likely we'll have to add 2 before NO2. So then, no, actually it doesn't make sense because we won't balance. We won't get an even coefficient before oxygen. So let's add 2 before copper nitrate and copper oxide. So now we have 4 oxygens on the left, then we have to add 4 before NO2, and now we can calculate number of oxygens. So here it's 2 by 3 by 2, which is 12, and here it is 8 plus 2, then plus 1. Now it's 12. So this reaction is balanced. Now let's move on. The next one is a reaction between NO2 and water, forming HNO3 and NO. So here nitrogen changes oxidation state from +4 to +5 when it's oxidized to nitric acid, and from +4 to +2 in NO. That's why it gets 2 electrons. Then the coefficient before nitric acid has to be 2. The coefficient before NO has to be 1. Then the coefficient before water is 1, and coefficient before NO2 is 3. Let's check. So we have 7 oxygens on each side, on the right, on the left, and 7 oxygens on the right, and 2 hydrogens on each side. Now balanced. Okay, now let's move on to the next one. Iron Yeah, solid iron reacts with sulfur, forming iron 2s3. Okay, so that's is pretty straightforward. So 2 before iron, 3 before sulfur. Then the reaction between HCN and oxidation of HCN, forming N2 CO2 and water. Yeah, for now let's add 2 before HCN, 1 before nitrogen, 1 before water, and 2 before CO2. So then we'll have to add a not integer coefficient before oxygen. So then let's double everything. Let's add 4 before HCN, 2 before nitrogen, 2 before water, 4 before CO2. So here now on the right we have 8 plus 2, 10 oxygens, then we have to add 5 before oxygen on the left. Now everything is balanced. Okay, let's move on to the last one. So which is the reaction between B5H9 plus oxygen, forming B2O3, and I think you mistyped water. It has to be H2O. So let's balance this equation. Yeah, this one will be a little bit more tricky, but we can do it. So if we simply multiply B5H9 by 3, we won't be able to balance water using integer numbers. That's why let's multiply it by 6. Then we have to add a coefficient of 15 before B2O3. And how many hydrogens do we have now on the left? On the left we have 6 times 9, which is 54 hydrogens. So it means that here we have to add 27. And now we need to balance oxygen. So here we have 15 times 3 plus 27, which is 72. 72 oxygens. So it means the coefficient here should be 36. So now we have to divide everything by 2. Or let's divide everything by 3. So then the coefficients will be 2, 12, 5, and 9. Because the sum of the coefficients has to be the lowest. So let's add 2 here, 12 here, 5, 9. And now let's check material balance. So 10 borons on each side. Okay, that's fixed. 18 hydrogens on the right. 18 hydrogens on the left, 18 hydrogens on the right. Now let's check oxygen. So 24 oxygens here, and here we have 15 plus 9, which is also 24. Yeah, that's balanced. So this problem is solved. I hope I helped you. Thank you very much for your attention. Bye.